Welcome to Electricity Part 2. So resistance means how strongly a wire or other object resists current flowing through it. Copper, you can see, has a very low resistance. You can see from the digital ohm meter. It's measuring how quickly the electricity can flow through it. And you can see the number is very low on that one. The glass, though, you can look at that, and it has a really high resistance. So if it has a high resistance and has a high number on the ohm meter, it's called an insulator. It resists electricity going through it a lot, okay, at a very high rate. Copper, on the other hand, is what is called a conductor. It has a really low resistance. It lets electricity flow through it. So conductors let electricity flow through very quickly. Insulators do not. Okay, the number, like the measurement of resistance is called an ohm, OHMS, and you can see the symbol that is used for it. Okay, you can think of resistance like this. We've got two bottles here. One has a small opening and one has a large opening. The one with the small opening on the left, it has a high resistance, a very small current flow. So that would be like very slow current of electricity going through. This larger bottle has low resistance, so it's got a high current flow. The current is going very fast. A volt is the term for pressure in the line, causing the current to flow through the wire. I bet you've heard about volts when you talk about like the voltage in your house or the voltage that a toaster uses, that sort of thing. Okay, so we talked a little bit about conductors and insulators. Conductors, it's the material through which electric charge can flow. So it's something that will let electricity flow through it. Metals are really good conductors for the motion of electric charges because their electrons are really loose. And you remember what electrons are. Those are the negative charges floating around the outside of the atom. Insulators, on the other hand, are materials where electrons are tightly bound. They don't float around real easily. They don't skip from one atom to the other. Remember, like scuffing your feet on the floor? Those let electricity, the electrons leave and connect to your feet easily. But materials that are not good conductors include rubber and glass. So you can see on these two wires, the conductor is the wire part, usually like copper in there, and the insulator is what's around it, the rubber. So electricity can flow through that metal portion, but that insulator around the outside keeps the electricity in there and doesn't let it jump out and hurt us or start things on fire. Okay, so power lines, you might think, okay, if you really look closely at a power line, I always thought that they were, just big wires and nothing around them. But if you look really closely, what happens is you've got wires running, like here's the wire running, it attaches to this, and then it keeps going. It's not attached to this big tower, okay? So the wire from about here, actually probably right here back, it's covered in a rubbery substance so that the electricity won't kill like a squirrel running across it, or if we touch it, hopefully we don't touch it, but if we touch it, it'll be covered in rubber so we don't get that shock. But right where it hits here, it actually is not covered in rubber. And up through this part, this is called an insulator, a ceramic insulator, so that the electricity, you can hold the wire here and let it go to the next location, but it won't be touching this metal. This metal, you don't want it touching there because then it will lose the electricity going into the air and it will shock things that touch it. We don't want that. So this insulator stops the electricity from actually running and hitting this right here. Okay, but those insulators are there just so it can hang there and go to the next power line. I guess, can't think of what those are called. Metal towers, I guess. Okay, so it just keeps going boom, 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 that sort of thing. So those insulators protect those towers from the electricity. Okay, semiconductors. Semi means halfway, right? And a conductor lets electricity go through, so halfway letting the electricity through. So we look at this and go, oh, materials that can be made to behave sometimes as insulators and sometimes as conductors. The atoms hold their electrons, those little negative charges, until given small energy boosts, and then they let the electricity flow. And then it stops the boost and it keeps the electricity in there, and then it gives it a little boost and it lets it flow again. So this occurs in photovoltaic cells that convert like solar energy into electrical energy. Solar energy is collected in these photovoltaic sheets, and it's just sitting there waiting for a little boost of energy. And at nighttime, let's say, or when the local town needs some of the energy, they just boost it, boom, and then it takes some of that energy away, some of the electricity, so that it can use it. A potentiometer, or a pot, we call it, it is used to adjust the resistance of the electrical current. So when we have a potentiometer, we can twirl this little button here, or this handle, and at 0, it's going to make it a really high resistance, so then the electricity can't flow through. And then when we crank it up to 10, it lets it flow through real fast. So this is like what is on a dimmer light. So if you have a dimmer switch in your house that turns maybe a chandelier up high and makes it real bright, and then it turns it really down low, it's really letting in more electricity or less. It's a resistor. So you can also think of that on your radio dial. If you turn the radio up, really you're making the resistance less so that you can hear the radio louder. Okay, a series circuit. Remember, a circuit is just a circle letting electricity go through. Okay. Now, a series circuit, there is only one path for that current. It goes this way. Remember, it goes out the positive end of the battery, down into the light bulb here, out to the next light bulb, out and back up. Okay? If one light bulb turns off, they're both going to turn off, because if you turn off the switch, the electricity stops the flow all the way around this whole circle. So it's going to stop both lights. Okay, so that's a series circuit. Now, what if you have a parallel circuit? That's a circuit with more than one path for the electricity to flow. This is how it's actually made. You have this big power box, and the electricity comes out, and we can splice it off and have a couple of outlets here, or a light bulb, or whatever, a switch, and it can go back in here. But we can also splice it off here and have another switch and light source. And then here, and another switch, or an electrical outlet, and back. That way you could have 3 different lights on here, and you turn one off, it's not going to turn all the other ones off. Okay? Most houses are wired for electricity in this way. If they weren't, if they were wired like that, once you turned one light off in your house or one outlet off, it would turn everything off in the whole house. And we don't want that to happen. So we put this into our houses, apartments, everything like that. And each device in the house can be turned on and off independently of each other.